Now, increasing and decreasing. If a is less than b implies that f of a is less than f of b for any a and b in the domain, then it's an increasing function. What's happening is it's going up from left to right. If a is less than b implies that f of a is greater than f of b for any a and b in the domain, then it's a decreasing function. It's going down from left to right. So look at increasing and decreasing and what it does, the graph does from left to right. If a is less than b implies that f of a equals f of b, then it's a constant function and it goes straight across. That's a constant function. It stays flat. Here we want to identify when is this function increasing, decreasing, or constant. When is it increasing? When is it going up from left to right? When is it decreasing, going down? And when is it constant? And we give these an interval notation. Well, right here, as I start from left to right, it's going down. So it's decreasing from negative infinity to 0. Use that bracket for 0 because that's where it stops decreasing. But at 0 it also starts increasing. So we would do a bracket to infinity. When is it constant or flat? Never. You can just leave that a line or make it the empty set. This one, when is it increasing, decreasing, or constant? Do pay attention to the arrows at the end of the graph. So this does have an arrow at the end. It means it's down there, goes to infinity. So going left to right, it's increasing from negative infinity. Over here, I go up to 1. It stops increasing at 1, so I use bracket. Decreasing, it starts decreasing at 1, so I do bracket again, and it does that to infinity. And of course, the arrow, again, it's never constant. Oh, we have a constant part here. So when is it increasing, when is it decreasing, and when is it constant? It's increasing between here and here. That's when it's increasing. And we give the x values. It's increasing from 1 to 3. And we'll use brackets. That's when it started stopping increasing. Decreasing, left to right, started at infinity, or negative infinity. And here at the 1, it stops, but this time it gets a parentheses because this open dot, not shaded in, means that point doesn't really count. So it just comes close to 1, doesn't really count. When is it constant? It's flat across here. It starts being constant at 3. We can use a bracket, and goes to infinity. Now, I've given you sketches of some of them. We also have, in your book on page 210 and 211, we have a function gallery. It has a picture of a constant function, the identity function, a linear function, a line, absolute value function, the square, square root, cube, cube root, and the greatest integer function. The greatest integer function is kind of interesting, but I chose not to teach it.